Okay, now I'm going to talk about the 21st question of TVO problem solving booklet. Um, okay, let's look at the setting of the problem. The T tetramer. First, we define what is a T tetramer. So the T tetramer is formed by 4 1 times 1 squares like this in the T shape, which is quite easy. And the rectangle R, we define what is rectangle R, has a dimension of 2a times 2b, which means the two sides of the rectangle are both even. The expression R can be tiled by T means R can be recovered exactly by copies of T without gaps or overlaps. So the setting of this problem is quite easy. So we're going to talk about in two cases. So the first case can all be tiled by T when both A and B are even. So the solution of this problem is quite obvious. As we can see, A and B are both even, right? So when we are meeting these kind of conditions, we just let A equals 2m and B equals 2n. Okay, so that's the extra condition we are given in the problem 1. Yeah. So we're gonna talk about it. So firstly, we write A equals 2m. Then the dimension of this R can be rewritten as 2 times 2m times 2 times 2n, which is 2a times 2b. Okay, so the dimension of this rectangle is 4m times 4n. So now, given this dimension, we can divide this rectangle by m times n, 4 times 4 squares. So what is in the 4 times 4 square? Firstly, we can sketch a 4 times 4 square, which is like this. So can we fill this 4 times 4 square up by T tetraminoes? So the answer is obvious. Firstly, we put our first tetramino like this, then the second, and the third one is like this, and the fourth one. So now we got the proof. So when when A and B are both even, we can know that the rectangle could be divided by m times n, 4 times 4 square, and each 4 times 4 square could be filled up by 4 tetraminos like this. So we got the proof of the first question. Now let's go to the second question. So setting is when A and B are both odd. So as we can know from the first question, when A and B are both even, we got the proof that it could be filled up. So we can probably guess when A and B are odd, we cannot fill it up. So how can we disprove it? So we need to know something called colorings. So what is coloring? So imagine if we have a chessboard. Chessboard. Usual chessboard is like 8 times 8, and for example, if we are taking random 4 consecutive squares in the chessboard, we'll find the color is black, white, and black. So I shaded these 2 squares which are black. Okay, so we can color the rectangles and the tetraminos by using the same way. So let's see, what if we color a tetramino? So in how many ways can we color this tetramino? So let's draw a tetramino first. It's like this. Okay. In our first case, we can talk about the central square here. The first case, the central square is white. You know, the neighboring squares must be black. So we got the case a tetromino could be filled by 3 black squares and 1 white squares. So then, on the second case, we know that the central square is black. And the neighboring squares are all white. So we also get 1 blue and 3 black. Okay, so let's go back to the rectangles. So you know, 2a times 2b is a rectangle. So let's think about this problem. If we can fill this rectangle by these t tetraminos, so how many t tetraminos should we use? So firstly, we're gonna talk about a tetramino. Take up 4 squares in the rectangle, right? So we can write the scales as 4 times a times b. Okay, so there are a times b tetraminos. If we can fill this square by just t tetraminos, you know. Okay, but as you can see, a b are both even, so a times b is also an even number. Okay, so if we are going to color this 2a times 2b rectangles up, we're gonna say we can divide this 2a times 2b into a lot of 2 times 2 squares, as we mentioned here. So let's talk about this 2 times 2 square. So what's the coloring is like within the 2 times 2 square? It could be like this or like this. So no matter what, we get 2 black and 2 white. Okay, so within this 2a times 2b rectangle, we do have equal number of black squares and white squares. So we got AB 2AB white squares and 2AB black squares. Okay, so let's go back to the tetramino. So we do have an even number, which is a times b, even number of tetraminos. If we are going to, if this rectangle could be filled up, and you know a times b is an even number, and we do have an even number. Odd number. We do have an odd number supply. We do have odd number of black squares in the tetramino, and we do have an odd number of white square in the tetramino. So, and the number of tetraminos that are going to fill up in this rectangle is also even. So imagine an even number of even numbers sum up. So the resulting So the resulting black squares should be an even number. Should be an odd number. Okay, sorry. I probably made some mistakes. By just saying it's odd number, not even number. So just know about it. I probably made some oral mistakes in my previous process of solving this problem. So now I'm gonna correct them. So a times b is an odd number, and if we have an odd number of odd numbers summed up, we get an odd number, which contradicts that we have two AB white squares and in the rectangle and two AB black squares in the rectangle. So we got a contradiction. So we prove that the 2A times 2B the 2A times 2B rectangle could not be filled up by the tetraminos if A and B are both even. So now this is a whole proof. So the second question is much more complicated than the first question, but in general it's an interview question which has a normal difficulty, and you're gonna made a lot of problems like this in your real interview. So yeah, that's my solution of the 25th question. Bye bye.